In this video, I would like to go back and just give a brief overview of all of the Excel functions that we've used so far in our study of descriptive statistics. So I have some randomly created data, and before we start doing any specific calculations, just recall, Excel gets more complicated than this, but for the purposes of what we've been doing, anything we're doing on Excel takes pretty much the same form, and that's an equal sign. So let's put me in the pen. That's an equal sign. The name of the function, and in parentheses, the data, or the location of the data. Let's say location of the data. Okay, so I have some data here in column A. So I have, two sets of data. One, I have this data here, which we'll use for all but one of these statistics. And down here I have matched paired data, which we need for the correlation coefficient. So let's just go through these one by one. And you'll see each one of these Excel functions is taking the same form. Name of the function, and in parentheses, the location of the data. So now I'm focused here on this data here in column A. We'll convert these to Z-scores as well. But let's take the sum of these numbers. Let's count how many there are. Let's find the maximum, minimum, mean, median, so on and so on. So first one, for the sum, the function is equal sum, parentheses, location of the data. And you could just click and drag over the data you want to use, or you could manually type in A2 colon A16, either way. All right, so the sum is 6.95. The count. You want to know how many numbers there are. Now, it's pretty easy to see that there's 15 numbers here, but let's just say if we want to use Excel, the function is equal count, and then the location of the data, A2 to A16. If we want the maximum, equal max, MAX, parentheses, location of the data. And if we want the minimum, equal min, parentheses, location of the data. It might not be a bad idea to, in your notes, have just a list of all the Excel functions we've used and how to apply them. Remember, mean is a statistics term. Excel is not a statistics program. It's a general data array program. So in Excel, we don't use the word mean. We use the more common word average. Equal average, parentheses, data. And for the median, it's equal median, parentheses, location of the data. Now, one thing I say here is please use correct rounding in your calculations. And the rounding rule for descriptive statistics is that all measures of center and variation, if they need to be rounded, are rounded to one more decimal place than the original data. The median we don't have to round because it's exact, but the mean we should definitely round this. And in the home tool palette, we'll use these icons here for changing the number of decimal places Excel is going to give you. And we'll round the mean to 3 decimal places. So that's following the rounding rule. 1 more decimal place than the original data. Original data has 2 decimal places, so the measures of center and variation, if they need to be rounded, are rounded to 3 decimal places. The sample standard deviation and the population standard deviation. So remember, there are 2 different formulas for standard deviation. There's the sample standard deviation, where we divide by n minus 1, and there's the population standard deviation, where we divide by n. And since those are going to give us 2 different numbers, there's 2 different Excel functions. Now the Excel function for standard deviation is equal STDEV, but for the sample version, you need a .s, and for the population version, standard deviation of the population, you need a .p. So Excel could distinguish which one of these formulas to use. So for the sample standard deviation, equal STDEV.s, and our data is A2 to A16. Or population standard deviation, equal STDEV.p for population, A2 to A16. And again, both of these we should round to 3 decimal places. Let's do the variance first. So same thing with the standard deviation. Same thing as with the standard deviation, the variance. The variance is just without the square root sign, but it's still, for the sample variance, we're dividing by n minus 1, and the population dividing by n. So again, Excel has 2 functions for this. The variance of the sample, it's equal var.s, .s for sample, okay, and the population variance equal var.p, and in parentheses A2 to A16. And these are measures of variation, so again, we'll round these to 1 more decimal place than the original data. So we'll round them to 3 decimal places, just like the mean. And we have the percentile. I'm just going to use the 25th percentile, but that 25 could be any percentile from 1 to 99 or 1 to 100. And there's 2 Excel, and so this is one of the things I talked about in my video on measures of relative standing, where I covered percentiles. There are multiple formulas for percentile. So everything that came prior to this, from the sum down to the population variance, all of these other calculations that we just had, all of these, any statistics book you pick up, going to have the same formula. But for percentile, there are different formulas for percentiles. And just to align this with the textbook that I'm using for this class, the percentile, so if you do equal percentile, you'll see EXC for exclusive or INC for inclusive. We're going to use the inclusive version of the percentile function. So percentile.inc, that's the one we're going to be using for this course. It's just neither one is more correct than the other. It's just they align with different interpretations of the idea of a percentile. So percentile.inc, and remember in Excel, array means a list of your data, right? So our data is here in column A. So for array, So here Excel is telling us in parentheses, Excel is telling us array, and then K, for the K is the percentile we're looking for. Okay, so our data is here. And if we want the 25th percentile, we're converting 25% to a number that's 0.25. And so here's the percentile function that we're using. So it's slightly different than the rest. We have to not only tell Excel the location of the data, but also which percentile we want, because there's 100 of them. So 0.27 will be the 25th percentile. And now for the correlation coefficient, so this wouldn't make sense to use this list here, because for the correlation coefficient, we need matched paired data. So for the correlation coefficient, there is array number 1 and there is array number 2. We need x's and y's. So for the correlation coefficient, the function is equal, CORREL, parentheses. Now you see Excel is asking us for array 1 and array 2. It's basically saying, what are the x values and what are the y values? So our x values are here, and then comma, and then array 2, our y values. All right, so there's our correlation coefficient. I'm going to go ahead and erase the standard deviation functions because we need a little bit more room to work with. Now the last one, the correlation or the coefficient of variation. I have it in blue, not yellow, because there's no built-in function in Excel for coefficient of variation. The coefficient of variation is equal to the mean divided by the standard deviation. And we already have those two things. We have the mean right here, and we have the standard deviation right here. Okay, so for the coefficient of variation, I'm going to say I need it to equal the mean of the data, which is this number right here. So I'll click on that cell, that's G13, and divide that by the standard deviation. Oh, sorry. Oh, I had that backwards. Let me... My apologies for that. Let's just redo that. Coefficient of variation is the standard deviation on top divided by the mean. So again, we have those two numbers there. So let's say equal to the standard deviation. It's a sample standard deviation. And we'll divide that by the sample mean. All right. And so we could use Excel in one of two ways. We could use Excel using their built-in functions, or we could use Excel as a calculator. So we have a plus, minus, times, divide, exponent key on the keyboard. And in this case, we're using the Excel like a calculator. And there's our coefficient of variation. Now we need to change that to a percentage. So I'm going to go to the Home tab, and in this drop-down menu where it says General, you could drop that down and turn it into a... Ooh, you want that cell. Drop this down and turn it into a percentage. Okay, so there's the coefficient of variation. And the last thing I want to do is just take all of these x values and convert them to z-scores. Okay, so we have our formula for z-scores. Each x value has its own z-score. It's the number of standard deviations that x value is away from the sample mean. And the z-score is equal to x minus the mean divided by the standard deviation. Now, I want to be real careful here because we're going to use another function in Excel, which is the freeze function. We're going to use the $sign. Okay, so this first z-score. So basically, Excel is great for repetitive calculations. We have 15, so we basically have to apply this formula, the exact same formula, 15 times in a row. So what we want to do is, I'll type it in once and then copy it down so Excel does the next 14 iterations for me. So in this cell, which is B2 up here, I want this cell to equal, and I'm going to put parentheses around the numerator so we could just have Excel follow the correct order of operations. So equal percent, the x value, the number to the left, minus the mean, close parentheses, and divide that by the sample standard deviation. All right, so that is the first z-score. Now what we typed in was equal parentheses A2, which is the x value. So here's A2 minus the mean, which is right here. So that's column G and row 13, so G13, and divided that by the standard deviation, which is G15. And that's fine. That worked. That is the z-score. The problem is, when we copy this down, Excel is going to change that A2 to an A3 and then an A4 and so on, which is what we want because that's where the data is. But the problem is it's going to change that G13 to a G14, which we don't want because G14 is right here. This is G14. We don't want to use that number. That's the median. And this G15 is going to change to G16 and then G17, and this is going to change to G15. So this is okay. This we don't want, and this we don't want. So we don't want that 13 to change. Every row we want G13. And every row we want G15 for the standard deviation. So what we could do is, basically what we're going to do is sort of freeze that 13 and freeze that 15. So it's 13 on the next row and 13 on the next row. And this would be 15 and another 15. Now, the way we do that is with the $sign. Okay? So let's get this out of the way. So what we should be typing is, we're still using these same three cells, the A2, the G13, and the G15. So we could say equal A2, which is the X, minus the mean, which is G13. But before the 13, we'll put a $sign. The $sign basically freezes whatever comes after it. So if there's a $sign before the 13, that G13 is going to stay G13. And then we'll divide this by the standard deviation, which is G15, and we'll freeze the 15, because basically there's 15 X values, and those 15 X values are in locations A2, A3, A4, A5, A6, A7, and so on. So we want that number next to the A to change, but for every one of those 15 X values, we're going to be using the same mean and the same standard deviation. So we don't want that G13 to change. We want that G13 to be G13 because that's the mean. And we want that G15 to stay G15 because that's the standard deviation. Okay, so I'm going to go back up here. Let me get rid of this arrow. I'm going to go back up here, and in front of that 13, I'm going to type in a $sign, and in front of that G15. So let's see what happens if I just, without the $sign. I mean, you'll know you did something wrong because when you copy this down, you're going to get some problems, because like on some of these you're dividing by 0 because you're dividing by this divided by G15, G16, G17, G18. Eventually you hit G21, which is empty, so you're dividing by 0. So if we put in a $sign before the 13 and a $sign before the 15. So now when I redo these calculations, or basically let me do this from the beginning. So typed it in once, basically what I have right here is typed in up here. And when I drag this down, so remember, if you want Excel to repeat a calculation you've done once or repeat a formula you've done once, either way, you move the cursor, you move the mouse over the bottom right corner, see the white plus sign changes to a black plus sign, and you click and drag. Okay, and so those are the Z-scores. All right, so that about does it. Now, one alternate method that you could use, I'm going to delete some of this stuff so we have some room, is to use the data analysis Toolpak. So if we go over here to the data tab, and if you don't see data analysis here, that's just because it's turned off. By default, when you download or buy Excel or Office, the data analysis Toolpak option is by default turned off. So you have to turn it on. And you see all these different statistical functions in there. And I'm going to click on descriptive statistics. This is what we basically just did. All of this, these are descriptive statistics. So I'll click on descriptive statistics. Okay. And then next to input range, that's our data. So input range, I'll highlight the data or just click and drag over the data, or you could type in A2 to A16 if you want. And well, it'll open it up in another sheet. Let me just copy this and bring this over. Let's put it maybe right here. All right, perfect. So, once we round some of these numbers, you'll see there's our mean, there's our mean, there's our standard deviation, there's our standard deviation. There's our variance. There's our variance. Now there's other values here that we haven't maybe discussed at this point. I don't think I've talked about kurtosis yet in any of my videos, or skewness yet, or standard error. The others we've talked about. So you see count, sum, maximum, minimum, range. So these are all these are some of the descriptive statistics, and these are sample statistics. All right, so either way, you could use the built-in formulas in Excel, which I'm stressing this method because everything else we're going to be discussing on Excel is using the same sort of structure, equal sign, name of the function, and in parentheses, location of the data. Or just to real quickly get a brief summary of the statistics, it's the Analysis Toolpak in the Data tab. All right, I hope this was helpful in terms of sort of reviewing all of the Excel functions that we've covered so far in descriptive statistics.